Greetings, you watch But Heard Developer channel. My name is Dima and I'm trying to implement a solution that will help musicians promote their content. Today I want to talk about full text search. I will tell you a little about the approaches and I will demonstrate my non-standard solution. The final decision will be specific, but I will try to make the video useful for everyone. So I will talk about several topics not directly related to full text search. I will start with a disclaimer. Full text search is a huge topic. There are many algorithms, approaches and ready-made solutions. Do not count on someone in 10 minutes video to provide you with the perfect solution and tell you about all the pitfalls. You should know and take the risks when choosing a decision. It is important to understand that full text search is not filtering by specific field or template. This is an optimized search for a collection of documents in the full document. Usually, independent of the programming language and framework, the standard implementation of full text search looks like this. First of all, we are deploying some full text search engine. The most famous, in my opinion, is the Elasticsearch. Next, we create some index. Index is a document scheme, can be perceived as a table in the database. Next, we copy the data from the relational database to the document-oriented database. One record or entity to one document. This is literally the normalization to a document database. And of course, we should transfer all changes to the document, usually using observers or triggers. If we want to search something, we make a request to document database. It is perfectly optimized for this and return identifiers to some related database records with some payload if we need it. For example, a text with indicating the found fragment for better user experience. Next, we send this data to the frontend or we make additional SQL requests to the database and send to frontend with additional data. And yes, the database can have changes. We can add, remove new column, add some related data, tags, keywords and etc. And we should send this data to the documented database. That's why re-indexing or creating new index for all our records is a normal and frequent process. So indexing time is an important indicator when choosing a search engine. But remember that the half the work of indexing is a sampling from your database. Next, we should look at the speed of the search on the server resources that the engine spent for its work. Next, we should look in language supported by engine. There are many exceptions, for example, language where one symbol is one word. And of course, we have to think about features. For example, search with typos or faceted search. And we also need to find a solution that our framework support, because writing them from scratch will be very difficult and expensive. For this issue, Laravel has a Laravel Scout package. Laravel Scout take care about synchronization, indexing and sampling from search engines. By default supports 3 search engines: Algolia, TypeSense and Meilisearch, but you can find a ready-made driver for Elasticsearch or maybe for some other engines. It would seem that this is it. Let's take some TypeSense, deploy it inside Docker and make search without problems. But we have one problem here. We go away from SQL. This means we cannot use filtering, sorting, some specific condition from some specific tables are not available to us. But yes, theoretically, we can implement all this logic inside search engine, and most likely it will work much more better than inside SQL database. For this issue, we should create very detailed indexes, manage synchronization with all relationship, what we can use inside filters or inside order queries, write complex reindexing logic, and etc. and etc. After all this work, we can make a very beautiful functionality. For example, make some faceted filters. You can see faceted filters inside online shops. When filters say if you select this checkbox, you will get only 2 records. And yes, it's cool, but Laravel Scout and any other packages do not support this. And the implementation and support of search functionality is very difficult. We should manage different migration for document database. We should write a lot of observers for any relationship. We should write complex sample requests for reindexing. And usually you cannot write tests for this, just because turn up Elasticsearch server for testing is very resource-intensive task. So most likely you will mock interaction services and got problems only on the stage server or in production. That is why on most sites you have one search input, but when you select some category, it is impossible to search inside search category. When you go to Pornhub, you cannot select Gonzo category and trying to find Step Sisters, but it seems like it should be easy because we have filtered so many records. So it is possible, but very expensive. So expensive that Pornhub couldn't afford it. So I can't afford it too. And of course I can manage it on the front end. I can using filters, but when I use search, just skip filters. But it is not convenient and I don't want to do this for user of my site. But it may be necessary in the future, sorry. In search of alternative, you will find that Postgres has its own full text search functionality. And believe me, it works quite well. We should denormalize our texts inside TS vector column type and wrap our search text inside text query function perfectly with language parameter. So TS vector create a specific text where he finds the root of words, compress them. TS query function use the same logic to find the roots of words and search inside TS vector. And this will work fine. For optimization, we could install Postgres extension with RAM index and we can get very good performance. But if we look on allowed language, we cannot find Ukrainian language and many others. But we can install a language by ourselves. Simply download some dictionaries and make some simple command. But I am not a great fan to use self-hosted Postgres server. I strongly recommend you to use hosted Postgres services. It is very useful. These services take care about scaling, about backups, about restore backups, updating, and etc. and etc. It is very convenient and costs adequate money. And here we got a problem. For installing some dictionaries, we should literally copy files inside source file of Postgres. No one hosted service will not allow us to do this. And the second reason why I don't want to use Postgres full text search, because we should create separate column for separate language. It is not convenient. So I went looking for other solutions and I think I found them. Postgres extension pgrunga. Grunga is separated full stack search engine and pgrunga is interface for connection Postgres with Grunga. Documentation is not perfect, but what we should do is simple create write indexes and use a write select operator inside var SQL condition. We can use indexes inside column type text, varchar, array of text, array of varchar, and JSONB. And inside JSONB, we can use different indexes, different setup for any property. So if I need, I can create perfect optimization index for any language inside my JSONB. This could be killer feature in future. But now I have tests in several languages and it works fine without any problem. You should spend some time for creating write indexes, but it is not so complex. pgrunga extension should be installed. You can use a ready-made Docker image, but I install it on Postgres image. I have a little problem here. I cannot install it on current version of Postgres. I have problem with Linux Alpine here, but I install it inside beta Postgres version. It is okay solution for me because release not so close. I believe Postgres will release earlier. And yeah, it can be difficult to install some extension on some hosted service. A lot of services has already installed extension list and do not allow others to be installed. But I have found services that promise to install all extension what I want. I hope this is true, and yes, this is a great advantages of those services. For test, I create potential real table bands and create index for column name, column synonym, array of texts. I'm going to save synonyms of band's name, for example, Red Hot Chili Peppers and RHCP, and localize it JSONB with band description and filled the table with exactly 1 million records, as you like. We promise I had a negative expectation, and what was my surprise when even a complex query with a left join and additional condition took an average of 1 to 2 milliseconds. I remember it is full text search on 3 fields at the same time, varchar, text array and JSONB. But I go next and try similar search, or search with mistakes or typo if you want. And it also work very fast, but have a two problem. First is critical. This search die with error when we use not indexes scan, and have a mistakes in algorithm, I believe, because when we use indexes scan in parallel, die too. Not for all requests, but die, and it is a big problem, as for me. And the second problem, this function don't work with JSONB. Oh, unfortunately, I cannot use it for now. Now the section SQL iceberg should know what explain doing, explain analyze run real query, and show show real request plan, and I know how hard it is to read explain log. So I strongly recommend you to use explain visualizing services. We can simply copy paste explain text, and we will get an easy to read block diagram. Here we should know secscan. Secscan scan table without indexing. In most cases it is bad, but if you have small table, SQL can perform use secscan even if index exists. Index scan is perfect variant. You can read what index use for index scan and bitmap index scan. First create a bitmap and next use it for scanning. This is all common knowledge. I want to talk about what to do when SQL Planner does not use index and we really need it, as in case of similar search with PKRUNGA. For this issue we can use extension pg hints plan, and using specific syntax we can force Postgres to use specific index. I will not do this for now, but you should know about this possibility. Believe me, it could be helpful. Also PKRUNGA can work with search score. It is not obvious syntax, but it works. We can set different priority for different column. And of course we can order by score. And about index creating time. On my local machine, complex index for varchar and text array and 1 million records was created less than 10 seconds, but index for JSONB was created in about 10 minutes. I believe it quite slow, but we don't need spend time for select some data, so maybe this is a good result. Also PKRUNGA support replication, so we should not have problem with scale. Also you should know that index take a lot of disk space, but as you know, disk space is cheaper, so this should not be a problem. And of course my favorite things why I'm going to use this technology: developers don't have to worry about anything. Simple create index, create some scoped filter method, and do not think about observer, about queries, and etc. and etc. PKRUNGA does everything for us, at least I hope. So I can't recommend you to use PKRUNGA because I don't know how it will behave on the server and in production, but I will definitely try to use it. My rate from now is 7 from 10, and it could be 10 from 10 if the similar search will work. And as I can see, the project is developing, so I hope it will work someday. And I have to say, if search is a main functional of your project, I strongly recommend you to use Elasticsearch. And also, I know that many people use full text engines as engines for recommendation systems. I can advise you to take a closer look at graph databases. And I want to say that there will be no recommendation algorithms in my project, and I can proud of it. Believe me, this will be an advantage over competitors. People who create content will understand me, and musicians create content. Now I'm going to talk about Laravel filters. Believe me, it will make your code even clearer. But first, I have to say Russia is a terrorist state, and also Russia is a fake state. Now the whole world sees it, and we can finally defeat it. Right now, any help from you can destroy the terrorist state. Please help Ukraine as much as you can. This is very important right now. Thank you. So go to code. It doesn't matter what you are doing, you most likely have a lot of filters on your lists. A lot of filters, a lot of sorting conditions. You can also have filtering depending on the role or involvement of one of another entity. Usually developers implement this logic directly in controller or in the action. And no matter did you use eloquent when function or if else statement, this makes the method very huge, and reuse of code and support is almost impossible. This is a common problem. For each solution, smart people create a design pattern called a filter. For Laravel, I can recommend a ready-made package, Eloquent Filter, and it's very simple to use. First of all, you should add filterable trait to your Eloquent model. After this, we can use scoped method filter. First parameter, we should send array of data. Usually it is query string from request validated. And second parameter, we should use a filter class. All methods inside this class should have a name like k inside array of filtered parameters, converted to Pascal case of course, and we can get a value from array as parameter of those functions. So if we have array search and some text, inside a search function we can get this text as parameter. This inside this class is query builder. So function was called every time when we send array with k equal to function name in Pascal case, and inside this function we can add some condition to query. It is very useful. Model can use use many filters at once. Also, filter class had setup method, and it is very useful to implement some constant access logic to, for example, filtering by the role or user affiliation to some entity. And of course, we can write filters that can be used by many models. And believe me, filters can make your code very, very skinny. You can have zero fat code classes, skinny models, skinny controllers, skinny actions, and etc. As for me, this method has only one disadvantage. It is very easy to cover filter class by unit tests, but Eloquent does not allow to mock models inside tests. And inside feature test, we should duplicate test methods for all entity who use this filter. But I have not clear bad solution for this issue. I dispatch specific event only on testing environment, and inside feature test I just check if this method was dispatched and with which parameters. It is not perfect solution, I don't like it, but I don't know how to do it better. If you know how to manage this without duplication, please write a comment, I will be very grateful. Only one piece of advice per package: I don't recommend you to use a filter by default for model, just because it's very easy to make one click and go to filter class from controller or action, then to go to model and find a method who return a default filter. And a couple of words about security. First of all, you should validate all filters, and you must use a request validated method. Please forget about request all method. And the second one, please be very careful when you write your own raw methods. For example, in my case, full text search method. Never insert user data directly inside query string. Always use setBind, addBind, or a second parameter inside raw functions to set variable or named variable inside query. It will save you from SQL injection, and this is very important. And also I recommend you to isolate order by logic inside filters. It is very useful, and it is not allowed to send a desk ask parameter by bind functions, so please validate it separately. As a conclusion, this video is not so much about technology. This video about choice. Usually you don't have a RND command which can test all possible solutions and choose the perfect one for your tasks. Usually you make a decision, sell it to the customer without being sure that it is perfect, and you have to live with the consequences of that choice. So every time you criticize a decision in the project, know that it was chosen in a very limited time and with very limited resources. So be adequate, support Ukraine, and make only the right choices. Thank you.